Hello, and this will be my first video on electronics and a project that I've been working on for a couple of weeks now. So I'd like to give a big shout out to a company called Adafruit. During this whole epidemic, they've been continuing to pay their staff, they've been continuing to try and get shipping out when they can, and they're also now in the process of helping to make emergency medical supplies. So big shout out to that company doing everything that they possibly can to help out in this time. So let me give you an overview of my project. So I like to do motorcycle racing and track days, and I have a track bike dedicated just to doing that. One of the things as a programmer and an engineer is I want to know things about what I'm doing on the bike and when I'm doing it, and that's not always easy when you're going full throttle down the straight or braking hard into a corner, to be cognizant of everything that the bike is doing and everything that I'm doing and the reaction that the bike's having from the things that I'm doing, my inputs, etc. So one of the things I wanted to do is build a data logger. So I'm pretty fortunate that my motorcycle has a data logger port, which gives me certain feeds off the ECU and off the bike itself, like the throttle position and the RPM. So one of the other things though is that, I wanted to get my GPS position, I wanted to get my lean angle, I wanted to get a camera stream, and I wanted all of this logged in a good way that I could then analyze the results and maybe even write some software to be able to do that. Bit of background for me, I'm a software engineer. I've worked in the video game industry for over 10 years now. Coming up for nearly 13 years, 14 maybe. I worked on some pretty cool games, Doom, Crisis 2, Crisis 3, an old PlayStation 3 game called Haze from a company called Free Radical. Anyway, so I'm not very good with electronics. I'm not amazing, but I know enough to be able to start plugging these things together, a bit like Lego, if you like a kid learning Lego for the first time. So, but I am good at software. So let me run through what I've got. So I bought an Adafruit Clue, which is a 9-axis IMU. It's got magnetos, accelerometers, gyros. It's got temperature sensor. It's got light sensor. It's got humidity sensor. And it's all in a package designed to work with Arduino. So it's Arduino compatible, if not running. It's even got Bluetooth on board, which is pretty cool. I have a breakout board that has a GPS chip, which has a serial connector on it, so I can just talk via a serial port to that. And alongside that, I have a Raspberry Pi Zero Wi-Fi with a camera board on it, so that should get me, that has mass storage as well, so that's got a 32 gig SD card in it, and I'm able to record video. Okay, and along with that, I bought a handy little set of buttons for my handlebars that I can do things with. So let me turn the camera around. Okay, so the buttons I was just talking about are here. So a couple of these are momentary switches, and a couple of them are just push buttons that will return. So the two buttons that I've got wired up so far are green to turn on the whole system, so that's connected to the power board and allows the powering of the Raspberry Pi and the Adafruit Clue. The blue one is what I'm going to use to start and stop telemetry capturing. So moving on, so that's all wired up into over here. So we got the blue switch over here and the green switch over here connected to the power rails. This is a little board from Adafruit, which allows me to charge a LiPo battery from a USB connector. So I have a LiPo battery also from Adafruit just down here. So that's a 2000 milliamp hour LiPo battery. This is the Adafruit Clue, which I've got my own software running on it. That's connected to a Dragon Tail, which is by Adafruit as well, which gives me a convenient breakout board. Here's the GPS breakout board with a TTL serial. So the yellow wires you see, they're going into the Adafruit Clue here. And then there's a serial port that talks to the GPS to get the current GPS data. And then there's a whole bunch of wires connected from the Clue over here to the Raspberry Pi. There's also the blue wires that you saw earlier, so when I press the button on the handlebar to begin capturing, all that is managed by the Raspberry Pi. So the Raspberry Pi software effectively gets a time date stamp, and it tells the video camera to start recording, and then tells the Clue to start data capturing. When that happens, it starts getting all the sensor data and the GPS data and packaging it up, and it sends that back across some of these wires via another serial port back into the Raspberry Pi. So let me zoom out a little. So here we are, I've got my handlebar button, I'm just about to head out on track and I want to record some data. I press that, it starts sampling. So at this point it's sampling GPS data, it's sampling all the telemetry data for the accelerometers and etc. from the Adafruit Clue, sending that all across to the Pi, and the Pi is dumping it onto its SD card along with a video capture. So hello, everybody wave to the Raspberry Pi. Okay, and then when I'm done, I just hit this blue button again and it stops the capture and puts the Adafruit Clue ready back to capture for another session. Now I'm going to switch over to the PC and show you what that looks like when I get the data off the Raspberry Pi. Okay, so here we are on my PC. I'm connected via FileZilla to my Raspberry Pi. The idea being that I'll have a laptop Wi-Fi hotspot set up, and I'll just be able to connect to the Raspberry Pi. Take this folder here, which is the data logger folder on the Pi, and copy it over into my documents folder. So now if I go ahead, and it's asking me if I want it to write because I've got some previous data in there that I didn't clean out, but that's okay. So now this is the folder once it's been synced across to my PC. So as you can see, today's date is the 27th of March, 3:20 p.m. and we'll see up here that the this file down the bottom is dated with the date and the time that I started the data logging, and in here there will be an equivalent video. So March 27th at 3:20 or 3:18 in this case, the video there. So if I run this video and show you what that looks like. So and then if I go back out and look at this particular file, so we'll notice that this is a whole bunch of just binary data that I dumped with some headers so that I could easily see what was going on during debugging. So let me pull up Hex Workshop and show you what that looks like. So here I've added all my structures to Hex Workshop so that you could see what they look like. So I've got my header which says sample, which we just saw in the file. Inside that I've got my temperature data, it's got timestamp, temperature, and then it's got some like header and footer data just so that I could debug what was going on. And as you can see, it says the temperature is 29.5 degrees Celsius, which is amazing. And then the accelerometer was showing that there wasn't a whole bunch of stuff going on because it was all basically just sat on my desk doing nothing. So and there's one of these structures for each sensor that I have connected, including GPS, humidity, pressure, the magnetos, gyros, etc. So I can expand this structure out as much as I like, and there are a number of samples in the file, and each sample actually comes with its own timestamps for these particular things. So using this timestamp, I'm able to reconstruct the timeline of all the data that I recorded during a particular session. So the idea being that I could go out on track with this recording, I would get a video and I'd be able to get graphs of all this different sensor data, including my position on the track and my lean angle, etc. How humid it was and what the current atmospheric pressure was like. And from that I can get a whole bunch of different things from the GPS as well, so longitude and latitude. I should be able to get height above sea level, a whole bunch of other cool things that GPS provides as well. So along with that, I mentioned earlier, I want to hook that up to my motorcycle's data log import. That will give me a few other things like gear position, throttle position, and RPM. Along with that, there are some pretty cool little potentiometers that you can put arms on. So this is a quarter-turn potentiometer, and you can fit a little arm onto this little head here. Try and get this on the camera. There you go. You can fit an arm to that and then stick that up behind your brake lever and have your brake lever push the arm, and then have an elastic band retract the arm when the brake lever is released, and that would give me brake position as well. So those things combined, and all the data for the GPS and the lean angle, that gives me a whole lot of stuff to analyze. So I'm super looking forward to the next phase of this project, which will be getting all of this in a box and tidied away, and getting the cabling all sorted out, getting that in a position where I can transfer it onto my motorcycle, and getting the extra bits from the data logger port hooked up, and then building my own analysis software. So this will be a whole bunch of graph data and map data. So I'm quite looking forward to that bit of it. It's going to be interesting. Some of this stuff I've done before, some of it isn't, so this will be real cool. I'll have a further update probably when I get that in a box and on the bike with the extra bits of data input from there, and then probably another update once I've got some software that can do the analysis side, which I can start working on now, given the fact that my strictures are able to be brought across from the kit. So I hope you enjoyed this, and I'm hopefully gonna get this added to Adafruit. They do like a weekly blog of projects that people are making. So appreciate your time, take care, and stay safe.